2012 Projectiles, question 3b. A particle is projected down an inclined plane with initial velocity 20 meters per second. The line of projection makes an angle of 90 degrees with the inclined plane, and the plane is inclined at an angle alpha to the horizontal. The particle strikes the plane of Q, and the range of the particle on the inclined plane is 1600 root 3 over g. Find the value of alpha, and then the magnitude of the rebound velocity at Q if the coefficient of restitution is a half. Okay, let's set up our accelerations first. We know we're going to have a positive acceleration now in the I direction, with the going down the hill, and we have an alpha in here. So we're going to have a minus g cos alpha for j or y, and minus g sine alpha for what I'll stick to the i's and the j's, but you could use x and y's. So let's start with the time it takes to get to Q. We have the range or the displacement in the j direction will be 0 at this point and this point, so we get 2 times for that. So we have the velocity is 20, so 20, I'll write the equation ut plus a half at squared, so 20t plus, well, it's going to be a minus g cos alpha, so minus g cos alpha and over 2 by t squared will have to be equal to 0. So t times 20 minus g cos alpha times t over 2 is 0. So this is my initial time, and 20 would have to be equal to g cos alpha times t over 2, so 40 divided by g cos alpha will be equal to my time. So if I put that into my s of x or I, at this point it's hitting the ground, so I know it's going to be a 0 for my u. So if I look at the s of I, I'm going to have ut plus a half at squared. So we have, it's going to be equal to 1600 root 3 over g. So 0 times t because it's hit the ground, and my acceleration was, I put in a minus here, I shouldn't have put in a minus here, that's a plus. So g sine alpha is my acceleration, so g sine alpha over 2 by t squared, and the t was 40 over g cos alpha, to be squared has to be equal to this 1600 root 3 over g. So if I multiply this out, I'm going to have g sine alpha over 2 by 1600 over g squared cos squared alpha is equal to 1600 root 3 over g. Okay, so I can definitely start cancelling things off here. My 1600, if I divide both sides, will go. This squared will go with this g. So I'm going to be left with sine alpha over 2 cos squared alpha is equal to, if I got all my g's, and I'm still a g in here, don't I? Actually, I could cancel that g with the one on the right. I can cancel that one and that one. So that's going to be equal to just root 3, just root 3. So cross multiplying, I'm going to get sine alpha is equal to 2 root 3 cos squared alpha. With a root 3 and a 2, you might be able to see the answer is 60 degrees at this point, I think it is. But let's just multiply it out and create a quadratic, and we will be able then to solve it. So we can, let's get it in terms of sine. So cos squared alpha plus sine squared alpha is equal to 1. So I'm looking for cos squared alpha, 1 minus sine squared alpha. And now I have my equation in one variable. So I'm going to get sine alpha, not sine squared alpha, sine alpha is equal to 2 root 3 by 1 minus sine squared alpha. So I'm going to get sine alpha is equal to 2 root 3 minus 2 root 3 sine squared alpha. So if I bring everything to the left, I'm going to get 2 root 3 sine squared alpha plus sine alpha minus 2 root 3 is equal to 0. So if I put these values into our calculator using the quadratic formula with my A, my B would be 1 and my C would be minus 2 root 3. I'm going to get two values. I'm going to get root 3 over 2, and that's where the 60 is coming from. And I'm going to get a negative, so it's not going to be negative in this case. So we can say sine alpha is root 3 over 2. Therefore, alpha is 60 degrees. So the sine of 60 up at this point, the sine of 60 is root 3 over 2, and the cos of 60 is a half. So you can see how you'd end up with the 2's cancelling. We get a root 3 over 2 on the right as well. So alpha is equal to 60. The magnitude of the rebound velocity is the magnitude of the rebound velocity at q of the coefficient of restitution is equal to a half. Okay, let's just jot that down, the magnitude. So what do we need to do to get the magnitude of the rebound velocity? We need v of x, or v of I, and v of y. So v of x is going to be equal to v is equal to u plus at. There's no u happening for x, it's going to be 0. So the v of x is going to be 0. And we had g, it was sine, wasn't it? Just double check. My accelerations, g sine alpha and minus g cos alpha, g sine alpha. So g sine 60 times the time, and we got what the time was, didn't we? We got the time was 40 over g cos alpha. So times 40 over g cos alpha, that's my v of x. So that's going to give me my root 3 over 2 and my halves. The 2's will cancel, so I'm going to get 40 root 3. My v of y, I should have kept consistent with the I and the j, but I'll continue with the x and the y since that's what I wrote here. It's going to be the 20. My u plus at, the 20 minus g cos alpha. It's not, we have the g sine alpha must be g cos alpha, so minus g cos 60 by my time, which was 40 over g cos 60. Oh, my g's and my cos 60s will cancel, so I'm just left with minus 20. That's going to give me, so my velocity of y is minus 20, and we know to get my y, what happens with the coefficient of restitution is that we multiply by minus the coefficient of restitution. So multiplying this by minus 0.5 will give me what's happening in the y. Like, so it's, imagine it's going 20 and it's slowing down by half of that, so it's going to be down at 10. So the velocity of y will be equal to 10 at this point. So the magnitude of it, the magnitude of the velocity vector is going to be the square root of 40 root 3 to be squared plus 10 squared, and that's going to give me, comes out at exactly 70 meters per second.